Meet Maya. She's got a big probability test tomorrow, and she's staring at her worksheet totally stumped. The question says, are these events independent or dependent? And Maya's thinking, what does that even mean? Does one event care about what the other event does? Well, that's exactly what we're going to figure out today. By the end of this video, Maya and you will know exactly how to tell them apart. Let's dive in. Before we compare independent and dependent events, let's make sure we're on the same page about what an event actually is. In probability, an event is just one outcome that we care about. Like flipping a coin and getting heads, that's one event. Picking a red card from a deck, that's another event. And the probability of an event is simply the number of ways it can happen divided by the total number of outcomes. Simple enough, right? Now let's talk about what happens when two events show up together. Okay, here's where it gets interesting. An independent event is when one event has absolutely no effect on another event. They go about their business separately, like two strangers on different paths. Maya's first example, she flips a coin and gets heads. Then she flips it again. Does that first flip affect the second flip? Nope. The coin has no memory. It doesn't know what happened last time. Each flip is totally fresh, totally independent. That's the key idea. No influence, no connection. Now flip that idea around, pun intended. A dependent event is when the first event does change the probability of the second event. This usually happens when you take something away and don't put it back. Imagine Maya has a bag of 10 candies, 4 red and 6 blue. She grabs one red candy and eats it. Now the bag has only 9 candies and only 3 red ones. The probabilities just changed. That second pick is now different because of the first pick. That's a dependent event. One action changes everything for the next one. Here's a secret trick Maya discovered that made everything click. Ask yourself one question. Does the first item go back before the second pick? If yes, you replace it. The sample space resets. The probabilities stay the same. That's independent. If no, you keep it out. The sample space gets smaller. The probabilities change. That's dependent. With replacement equals independent. Without replacement equals dependent. Write that down because that one trick will help you answer almost every question on a test like this. Maya's basically already passing the test right now. Once you know whether events are independent or dependent, you can calculate the probability of both happening. For independent events, just multiply their probabilities together. It's that clean. For dependent events, you need to update the probability of the second event first and then multiply. The formula looks the same, but the value of P of B changes after event A happens. Don't worry, we're going to work through examples of both right now, step by step. Maya's ready, and so are you. Let's go. Let's solve Maya's first practice problem. She flips a fair coin twice. What is the probability of getting heads both times? First, let's find the probability of heads on the first flip. There are 2 outcomes, heads or tails, and one is favorable. So P of heads equals 1/2. Now the second flip, the coin doesn't remember the first flip, so P of heads is still 1/2. These are independent events, so we multiply. 1/2 times 1/2 equals 1/4. There's a 1 in 4 chance of flipping heads twice. Maya circles her answer, 1/4. Maya tries the next problem. She rolls a 6-sided die twice. What's the probability of rolling a 3 both times? On the first roll, there are 6 possible outcomes, and only one is a 3. So P of rolling a 3 equals 1/6. Now the die resets completely. It has no memory of the first roll. The probability of rolling a 3 again is still 1/6. Independent events, so we multiply. 1/6 times 1/6 equals 1/36. There is a 1 in 36 chance of rolling a 3 twice in a row. Pretty rare. Maya's getting the hang of this. Now for a dependent event. Maya has a bag with 5 red candies and 3 blue candies, 8 total. She picks one candy without looking, eats it, and picks again. What's the probability she picks red both times? First pick, 5 red out of 8 total. P of red equals 5/8. Now she eats the red candy. It does not go back. The bag now has only 7 candies, and only 4 are red. So P of red on the second pick equals 4/7. Now multiply. 5/8 times 4/7 equals 20/56. Simplify by dividing both by 4. That gives us 5/14. Maya got it. Last example, and this one's a classic. Maya draws 2 cards from a standard 52-card deck without replacing them. What's the probability both cards are hearts? There are 13 hearts in 52 total cards, so the probability of the first card being a heart is 13/52. She keeps that card out. Now the deck has 51 cards, and only 12 hearts remain, so the probability of the second card being a heart is 12/51. Multiply them. 13/52 times 12/51 equals 156 out of 2,652. Simplify. That equals 1/17. Impressive, Maya. She solved the hardest one. Look at Maya now. She's flying through her worksheet. Let's lock in a quick cheat sheet for spotting the difference. Coins, dice, and spinners are almost always independent because you reset them each time. Drawing from a bag, deck, or box without putting things back is almost always dependent. The golden question is always, does the first event change what's possible for the second event? If the answer is yes, dependent. If no, independent. Keep that question in your back pocket and you'll ace every probability problem. Here's the cool part. You use probability every single day without even realizing it. Think about the school carnival. Spinning the prize wheel twice? Independent, because the wheel resets. Picking names out of a hat for teams in gym class? Dependent, because names don't go back in until everyone's picked. Even dealing cards for a board game is a dependent event chain. Once you know how to spot independent and dependent events, the world starts looking like one giant probability problem, and you've got the key to solve it. Parents and teachers, this is a fantastic concept to explore together with everyday examples at home. Remember when Maya was staring at her worksheet totally confused? Look at her now. She just finished every single problem. Here's our full recap. Independent events don't affect each other. Multiply their probabilities directly. Dependent events do affect each other. Update the second probability first, then multiply. The quick test? With replacement means independent. Without replacement means dependent. And the formula is the same for both. Just make sure your probabilities are correct before you multiply. Maya's ready for her test, and so are you. You've totally got this. Now go practice and show everyone what you know. Before you go, here's a challenge. Try 5 probability problems tonight on your own. For each one, ask yourself that golden question. Are these independent or dependent? Use the with or without replacement trick, set up your multiplication, and simplify. You'll be amazed how fast you get at these. If you found this video helpful, smash that like button and subscribe for more math videos just like this one. And hey, if Maya can go from completely confused to totally confident in one lesson, so can you. You're a probability pro now.